Okay, on number 34 in section 4.7, you're asked to find the dimensions of a cylinder that has a volume of 1 cubic meter of minimal cost. So we want to minimize the cost. If the top and bottom are made of a material that costs twice as much as the material for the sides. Okay, so the cost function is equal to whatever the cost is, it's twice as much for the top and bottom as it is for the sides. So you can do twice times the surface area of the top and bottom plus the material for the sides, the surface area for the sides. So on a cylinder, you might want to just think about this for a minute. The volume of a cylinder is pi r squared h. The surface area of a cylinder, well, you have two circles. The top and bottom are circles, so they're just pi r squared. You have two of those. Now, the side actually opens up and makes a rectangle. If you imagine this rectangle, you can wrap it to make kind of form the sides of like a Coke can. And this right here is going to be the circumference of the circle. So that's 2 pi r, and then this is the h. And so you have 2 pi r h. So it's 2 pi r squared plus 2 pi r h is the surface area of a cylinder. Now, and we know that this volume is equal to 1 cubic meter because you're told that. Okay, so your cost function is going to be 2 times the surface area of the top and the bottom, which is just 2 pi r squared. So 2 times pi r squared plus the surface area of the side, which is this 2 pi r h. And so immediately you see that you have some trouble here because you've got this h is in the function. And so what you want to do is solve the volume equation for h. So then h is going to be equal to 1 divided by pi r squared. And so your cost function is going to be 4 pi r squared plus 2 pi r times 1 over pi r squared. So your pi's cancel and you'll have an r that'll cancel. So you're going to get 4 pi r squared plus 2 over r. And so you can take that derivative, is going to be 8 pi r plus, think of this as 2r to the negative 1, so this is going to be minus 2r to the negative 1 minus 1, which is negative 2. So this is 8 pi r minus 2 over r squared. So you're going to get a common denominator there, multiply this one by r squared over r squared, so you get 8 pi r cubed minus 2 over r squared. Now, a fraction equals 0 when the numerator equals 0. You set this equal to 0 to find the critical number. It's also where it's undefined, but that doesn't matter here because that's where the denominator equals 0, which doesn't make sense. So you're going to get r cubed is equal to 2 over 8 pi because I set that all equal to 0 and solve it. So you move the 2 over, divide by 8 pi. And so then r is going to be the cube root of 2 over 8 pi. Now, to find your second derivative, to verify that this is a minimum, you're going to do 8 pi, and then that's going to be plus, the 2 comes in front, so that's going to be 4r to the negative 3. Now, for any positive r, this will be positive, which means it's concave up. So specifically for the cube root of 2 over 8 pi, which is your critical number, it will be a min. So, I mean, it will be positive for our critical number, so it is a minimum. So a radius of the cube root of 2 over 8 pi will be give you a minimum, and then you can just plug in to figure out what your height is. Where was our formula? Our height is 1 divided by pi r squared, so the height is 1 over pi r squared. So just type all that in, 1 over pi, and then you have to do the cube root of 2 over 8 pi, and then square that. So it's kind of messy, but you can do that on your calculator to get the answer. I'm running out of time, so that's it.